Hello guys, welcome to Instantaneous Speed, Instantaneous Velocity. Previously, I talked about the concept of average velocity and average speed. You can find the link of this video in description. But anyway, today also I will have a short review over those concepts. I will start from the concept of instant and then I will continue with instantaneous speed and instantaneous velocity. Suppose that this is a time axis and then an event started from t1 and ended at t2. Let's say t1 is 10 seconds and t2 is 15 seconds. Basically, we expect the delta t, the duration of that, to be 15 minus 10, which is 5 seconds. That's all. Now let's consider a very short time interval in which t1 is 10 seconds, but t2 is 10.002. Here the delta t is going to be 10.002 minus 10, which is 0.002 seconds. You see the time interval is getting much smaller. What if t2 tends to t1, in which the delta t tends to 0? Very short time interval. In this conceptual case, we can say the delta t is so small that it's considered to be an instant. So the instant is a very short time interval. Whatever you measure in that short time interval is called instantaneous value, like the instantaneous force, instantaneous acceleration, and instantaneous velocity. That's all. Now let's continue with the concept of instantaneous velocity. Look at this car. Suppose that the car starts from here, goes on a straight line to the right, and this is the end of the journey. Let's say this journey takes a delta x of 1000 meters in 20 seconds. To find the average velocity, we should divide delta x by delta t, total displacement over total time. If I plug in the values, I will have 1000 meters over 20 seconds, which is going to be 50 meters per second. Means that in 1 second, the car will have a displacement of 50 meters in average. In average, 50 meters in each second. What about the special moment? For instance, at t equals 8. Do you know how much is the speed of the car at that moment? No. Average velocity is just telling you a whole view over the motion. It is not telling you the exact value of the speed at the special moment like t equals 8. What should I do for that? Basically, we should check the speedometer of the car. Let's say the speedometer indicates 60 meters per second. What does it mean? How the speedometer works? How the speedometer knows that the speed at that moment is 60 meters per second? We know that the speedometer works like this. Basically, it takes a very short time interval like t equals 8 and t equals 8 plus delta t, in which delta t is very short. So the corresponding delta x during that short time interval is going to be too small. So it takes the ratio of delta x over delta t again, in which delta t is tending to 0, delta x also approaches 0, and so this ratio is something you read on the speedometer, which is 60 meters per second. This is the concept of instantaneous speed. So we can say speed of an object at a moment is called instantaneous speed. What the moment is? Moment is a very short delta t, in which it tends to 0. What about the average velocity? Basically, if you include the direction, it is called instantaneous velocity. Let's say it's 60 meters per second with no direction. It's just the speed. But when I say 60 meters per second to right, I include the direction, it is the velocity. That's all. Let's develop the concepts to xt graph. What is the interpretation of instantaneous velocity or instantaneous speed over xt graph? For this purpose, I need some mathematical tools like secant line and tangent line. This is a yx graph in mathematics, okay? We are just reviewing some mathematical tools. I have a curve here. Let's take a point of interest here with coordinates of x1 and y1 and the other point of interest like x2 and y2. The secant line by definition is a line or a segment connecting these 2 points. This is the second line, okay? I want the second line to be a part of the graph. As I have no control on the graph, I should make a strategy here to take a second line to be shorter, to be closer to the graph. To do that, I can take x2 closer to x1. You see, when I take x2 closer to x1 and I draw another second line, the second line is a better estimation for the graph. It's going to be a part of the graph. It's now at smaller distance to the graph. And so if I take x2 closer to x1 and again closer to x1, I see that the second line is almost part of the graph. So in limit, when x2 tends to x1, basically the second line is a part of the graph. And if you extend that, you will have something which is called tangent line. Guys, we are back to physics. Let's go back to xt graph again. This xt graph starts from t1 and x1 and ends at t2 and x2, okay? Let's make the second line here, okay? And to find the slope of the second line, I should establish a triangle. Here I have x2 minus x1, which is the height of this triangle, and the base is t2 minus t1. You remember, the average velocity was delta x over delta t, which is x2 minus x1 over t2 minus t1. What you see here is exactly the slope of the second line. So the slope of second line on xt graph is average velocity. What about the instantaneous velocity? Instantaneous velocity is average velocity when delta t tends to 0. So t2 must be very close to t1. What should I do? I should take t2 closer to t1. No, it's not good. Let's take it closer. No, it's not good. Let's take it, it's not, I think it's better. Now t2 tends to t1 almost, and so when I establish a triangle, the second line here is a part of the graph, which is called the tangent line. If you find the gradient or the slope of this tangent line, it's going to be instantaneous velocity. So instantaneous velocity is limit of delta x over delta t when delta t tends to 0, the slope of the tangent line or the gradient of the tangent line. The slope of the xt graph sometimes is called the slope of the graph. What do I mean? Look at this. Suppose that the xt graph is given like this, and I'm going to find the slope of the graph at t equals 5, okay, at this point. Basically, at this point, first I should draw a tangent line, which is touching the graph at just one point, and then I establish a triangle. Let's say the vertical is, the height of this triangle is 10, and the horizontal is maybe 20, whatever. So the velocity, which is the instantaneous velocity, is 10 over 20, the slope of this tangent line, which is 0.5 meters per second. This is the slope of the graph at this point. The speed of the velocity of the motion at this point. That's all. For the other point, you should do the same thing and find the other slope. Look at this graph. In the following xt graph, okay, this is the blue curve. Find the instantaneous velocity of the motion at t equals 9. Okay, tangent line at t equals 9 is seen on the graph. Tangent line is exactly this green dashed line, okay, here. The slope of this dashed line will be the slope of the graph at t equals 9. To find the slope, I should establish a triangle, and fortunately this auxiliary point 6 is given to me to make me able to find the slope. Vertical over horizontal. Vertical is 36 and the horizontal is 3, so 36 over 3 is 12. Good. So 12 meters per second is the velocity of the motion at t equals 9. Part B, find the average velocity from t equals 0 to t equals 9. Average velocity is the slope of the secant line. Secant line from where to where? 0 to 9. Okay, so let's draw the secant line from 0 to 9. Then I establish another triangle. Then again, vertical over horizontal. Vertical is 36, horizontal is 9. 36 over 9 is going to be 4. So 4 meters per second is the average velocity from 0 to 9. You see, the instantaneous velocity at t equals 9 is different from the average velocity from 0 to 9. Why is that? Because xt graph is a curve. Look at this example. in which xt graph average and instantaneous velocities are the same. Look at the graph A. It's a line. Okay, let's take the whole motion from here to here, and then I establish a triangle and find the slope. If the slope is 10 meters per second, means that the average velocity is 10 meters per second here, okay? But what about the slope here? Of course it is 10, because this is line. The line by definition will have the same slope everywhere. So the slope here also is 10. The slope here also is 10. If you establish another triangle here, it will have the same slope. That's all. But in the other one, in the other graph, the graph B, it's different. Let's take the whole motion from here to here. It's the secant line, you see? And if I establish a triangle and find the slope to be 10 meters per second, it is not necessarily the slope of the graph also here. You see, it is different because it's a curve. So in the xt graph, which is not linear, we cannot necessarily say that the instantaneous velocity and average velocity will have the same value. Sometimes they may have, but not necessarily. Let's continue. Extremum points on xt graph. Extremum means minimum or maximum. Okay, look at the first one, the left one. Here I see the graph is ascending here and the velocity is positive because if I draw a tangent line, it has positive slope. At maximum point, the velocity is 0 because there is no slope. The maximum point, the slope will be 0. So the object will stop. And after that, the velocity is negative because if I draw a tangent line, it will indicate the negative slope. So the direction of motion will change at the maximum point. Maximum point is a point at which the object will stop and change the direction of motion, because before that, the object is going to the positive direction of x, and after that, to the negative direction of x. Look at the other one. Here, the velocity is negative because the graph is descending and the slope is negative. And here at the minimum point, the slope is 0, and after that the velocity is positive because the graph is ascending. That's all. So in extremum point, the object will stop and change the direction of motion. In the following xt graph, instantaneous velocity of an object at t1 is negative 4 meters per second. Means that if you draw a tangent line here, it will have a negative slope and the value is negative 4 meters per second exactly. What is the instantaneous speed at that moment? You know, the speed cannot be negative because speed is scalar. How to find the speed is very easy. Just take the absolute value of the velocity. If the velocity is negative 4, the speed is 4. That's all. The magnitude of velocity. The speed is scalar. But the velocity is vector. And because of that, the velocity can be positive or can be negative. When I say the velocity is 4 meters per second, means that the object is now has a displacement of 4 meters in each second. Rather than that, it's going to the positive direction of x. Okay? When I say it's negative 4 meters per second, means that the object has a displacement of 4 meters in each second, but to the negative direction of x. But when I say the speed is 4 meters per second, I know that just the distance traveled is 4 meters per second, 4 meters in each second. I don't know to which direction. Okay. Speeding up or slowing down motion on xt graph. Look at the left one. Here the slope of the graph is something. Later time the slope is larger, you see. So the velocity is larger, but for checking the speeding up or slowing down motion, we do not pay attention to velocity, never ever. We just take the speed. So forget about the negative sign. Even if the velocity is negative, I just consider the absolute value. Here I say the speed of the graph is something like 4, and here the speed is something larger, maybe 10. So it's speeding up. Speeding up. The other one, here the speed is something, let's say the speed is 10, and here at later time, the speed is smaller because the slope is smaller. So the speed may be 3. So here I say it's slowing down. It is very important in the cases when the velocity is negative. Look at the left one. Here the velocity is negative, but I do not notice the velocity at all. It's just the speed, which is important for me. The speed here is, I don't know, 4 meters per second. It cannot be negative. Later time, as the graph is more descending, so the speed has larger magnitude. So the speed may be 10 meters per second. So here I say again, the object is speeding up. Forget about the negative sign of the velocity. The other one, at this moment, the speed may be something like 10 meters per second, and later time, the speed is smaller, maybe 2 meters per second. So I say it is slowing down. It's very important that in determining the slowing down or speeding up motion, I just check the speed, means the magnitude of the slope, not the velocity. This lesson came to its end, and I'm again thankful to you because of being with me. Take care. See you in the next video.